Today we're going to learn how to graph inequalities on the coordinate plane. Why do we need to graph inequalities on the coordinate plane? Well, sometimes our inequalities have more than one variable. So when they have more than one variable like x and y, we end up putting them on the coordinate plane. Let's see what that looks like. So the first thing to know about graphing inequalities on the coordinate plane is that these symbols of open and closed circle can no longer be used. However, we still need to be able to show things like less than or equals to, greater than or equals to, as opposed to like less than or greater than. So instead of using the open and closed circle, what we use instead is a dashed line. Dashed line goes with less than and greater than, and also a solid line. Solid line goes with less than or equals to and also greater than or equals to. The other thing that changes is instead of shading to the left or to the right, so these are out, we now shade either up or down. So if you shade down, this would be for less than. And if we see greater than, we would be shading up. So again, shading down would be for less than, but also less than or equals to, and then the shading up would be for greater than or equals to. Okay, remember when we are graphing a line that this number here at the end, this is our y-intercept. That is the one that shows up as a dot on the y-axis. Remember that this number here that's next to x, this is our slope. The top number always tells us how far we go up or down, and the bottom number tells us how far we go left or right. So for this particular equation here, y is greater than 2/5 x plus 2. My first step is going to go to positive 2 on the y-axis, which is right here, and put a dot. Then for my slope, it says that I'm going to go in a positive 2 direction, which would be up 2 more squares from where I left off. And then a direction of a positive 5, which would be to the right. So up 2, right, 1, 2, 3, 4, 5. And before I just automatically make a line, I'm going to check what my symbol here says, and it's greater than or equals to. Because of the equals to part, I have to sketch a solid line, and because it's greater than, we will end up shading everything that is over top of this line. Next example, y is greater than or equals to 5 over 2x minus 5. Don't forget, if your y-intercept is a negative number, that means that it's going to be near the bottom, so I'm going to count down 5, 1, 2, 3, 4, 5. And put my first dot. The slope again is positive 5, so that means that I'm going to count up 5 from the dot that I left off at. 1, 2, 3, 4, 5, and there's a positive 2, so that means I'm going to go to the right and put my second dot. Again, this is greater than or equals to, so I'm going to sketch a solid line through the 2 dots, and because it's greater than, I will shade everything above. Okay. Next example, y is less than negative 3/2 x minus 1. We're going to start by counting down 1. And this time, because the slope is negative, we're going to end up going down first and then to the right. Now, I know a lot of people would be tempted to go down and to the left, but here's the tricky thing about this one. See how there's only one negative number? We're only going to use that negative sign once with one of these numbers. So we're counting the 3 like it's a negative, and then the 2 is a positive. So that's how this one ends up working out. So I'm going to go back to negative 1. I'm going to count down 1, 2, 3 squares. And since it's positive 2, I'm going to count 2 to the right. When I get to my symbol, it says y is less than. Since there's no line underneath, that means that I have to do this as a dashed line through these 2 dots, and less than means that we will shade below. So here is below the line. Okay, we're going to get a little bit more practice with negative slope in this one. It says y is greater than negative 3/4 x, but there is a number missing. Remember, if you have a number missing at the very end, we just write in a +0. So that means that our dot on the y-axis would be smack dab here in the middle at 0. And then since the slope says -3 over 4, that means that we're going to end up going down 3 and then we're going to go right 4. So here's down 1, 2, 3 and right 1, 2, 3, 4. It says y is greater than. This is going to be a dashed line, and I'm going to shade everything above this dashed line. So that would be this way. Okay, next example, y is less than or equal to 2x minus 4. Our y-intercept is -4, so I'm going to count down 1, 2, 3, 4 and put a dot. When I get to my slope, we are missing a number. Remember, when we're missing a number, we can always write 1 in underneath, like we can write 1 in literally. So I'm just going to draw a line and put 1 underneath. +2 means I'm going to count up to, and +1 means I'm going to count 1 to the right. This is y is less than or equals to. The equals to part means that I'm going to sketch a solid line through my dots, and because it's less than, I'm going to shade underneath the line, which is right here. Next example, y is greater than or equal to x plus 1. This one's really tricky because it has, well, there's literally nothing here in front of x, but remember, anytime we have a number missing in front of x, we can write 1 in, and we can also write 1 underneath. So this says that we're going to start at +1, which is up 1 on our y-axis. The slope then is 1 over 1, so I'm going to count up 1 and over 1. According to the symbol, y is greater than or equals to. The equals to part means I'm going to sketch a solid line, and because it's greater than, I am going to be sketching above. Alright, these last two examples are our trickiest. We're going to be starting at -3 on the y-axis, so I'll be counting down 3 and I'll put a dot. Then it tells me that I would need to go down 6 and over 5. Now, for the amount of room that you guys have on your graph, you would not have room to go down 6, even though I do. So I'm going to show you what would happen if we're assuming that like the only amount of space that you would have on your graph is in this little tiny window right here. See, no room to go down 6. So if something like this happens, since we cannot fit down 6 over 5 on our graph, is we can just send the negative sign to the bottom and leave the top number as positive. So instead of doing -6 over 5, we'll treat it like it's +5 over -6. Believe it or not, this would still give us the same graph. It's just a lot easier for you than trying to count outside of the window that you have available. So I'm going to go back to -3, and I'm going to count up +6. 1, 2, 3, 4, 5, 6. And then the bottom number is -5, so instead of going right like we're used to, this time we're going to count left. 1, 2, 3, 4, 5. That's where my second dot's going to end up being. It says y is less than or equals to. The equals to part, remember, means that we need a solid line, and because it's less than, you would just end up shading the space underneath. Alright, last example. Y is greater than 7 over 2x plus 4. We're going to start by counting up 1, 2, 3, 4. Now remember, if this was your graphing window, you would not have enough room to count up 7 and over 2. So in order to make that fit, we would end up changing the direction for both. So if we do not have room to go positive, we'll go negative. But if we do not have room to go positive on top, that means that we also have to go negative on the bottom. So since we changed one direction, we actually have to change both directions for this one. So I'm going to count down 1, 2, 3, 4, 5, 6, 7, and then since it's a -2 on the bottom, I'm going to count 2 to the left. Hey, look, I got it to fit. The reason this works out, doing the double negative, is because when I actually do like my line through these two dots, which I would have to do as dashed because there's no line underneath, this would make a positive slope. Remember Slope Dude from last quarter, puff, puff, positive? Here he is going puff, puff, positive off the line. Even though we initially counted it as a double negative, it still works out that he's skiing up puff, puff, positive. The only thing that's left to do with this line is it says its y is greater than, so I would be shading above the line, which is all the airspace over top of Slope Dude. That's it to graphing lines. Thanks for watching.